is one of the challenging calculations for empirical formula, and I'm giving you hints already about it. So pause the video and try it yourself, because I'm gonna go through the solutions very, very soon in 3, 2, 1. Let's go. So as you can see, we have the mass of an oxide, of manganese oxide. Okay, this is a different reaction that you're normally used to. You might have seen like combustion reactions, but the concept is really, really similar. And what I would suggest you to do is, first of all, to write down the equation, because there is a chemical reaction taking place, isn't it? So we have the manganese, we don't know how many there are, oxide, we don't know how many oxygens there are, and it's reacting with hydrogen. Okay, the product of this reaction is written here, is water and manganese. Now, the very important thing to realize is that you have the Y number of water molecules. And why is that? It's because notice how the ratio between water and oxygen, first of all, it's 1 to 1. But then also the ratio between the manganese oxide and the amount of water. Basically, if you had to balance this equation, you will get the Y number of waters, okay? Because you have to balance the oxygen and an X number of manganese. Okay, so having the equation down is very important so that you can understand this concept of ratio, because if you understand this, and I'm going to clear up because I need a bit of space, you will realize that what you can find is the number of moles of water. And therefore, this number of moles of water will be the same as the number of oxygen. So let's see that. And then the moles of oxygen, therefore, we calculate it as the moles of water. It's 0.235 divided by the MR of water, which is 18. So we're going to have this 0.013 moles of oxygen. So we have the total mass of the oxide, of the manganese oxide. So we're going to need to find the mass of the oxygen. Okay, because in this way we can find the mass of the manganese. And when you have two different masses, you can just find the moles and the ratio, just like when we do with the empirical formula. So we have, if we times this by 16, 0.208 grams of oxygen. Okay, now that we have that, I'm going to clear this up. We can find the mass of manganese. So the mass of the manganese will be 0.688 grams minus the amount of water that we have, therefore will be equal to 0.48 grams. Okay, now that we have the two masses, notice how it's going to be the same as the empirical formula calculation. So let's do that. If we divide this by the MR of manganese, which is 54.9, and this by 16, which is the mass of oxygen, we get the moles, which is 0.00874 moles and 0.013 moles. Of course, we divide each by the smallest number, which is the 0.00874, and we will get the ratio. Is it a full ratio? No, because we have 1 and 1.5. But this should give you already the idea that what is the ratio if you have 1 and 1.5? We times it all by 2, so it's going to be a 2 to 3. Therefore, C is our formula. I know it's an intense calculation for the empirical formula, but I hope you give it a chance. Otherwise, you should check the worksheets on the Google Classroom, because there is an empirical formula that will help you with this.